Black holes are some of the most mysterious and terrifying objects in the entire universe. Imagine you are drifting through the vastness of space, far away from Earth, when suddenly a shadow appears ahead of you. At first it looks like an ordinary patch of darkness, but then you notice something strange. The stars behind it are bending, their light curving into arcs as if space itself is distorted. What you are looking at is no ordinary shadow. It is a black hole, an object so powerful that it bends the fabric of space and time around it. The question many people ask is simple but chilling. What would happen if you fell into one? Would you be destroyed instantly, or would you experience something so strange that human words can barely describe it? To begin answering that question, we need to understand what a black hole actually is. Black holes form when massive stars, many times larger than our own sun, reach the end of their lives. Throughout most of a star's life, there is a balance between two forces. On the one hand, nuclear fusion at the star's core produces heat and energy, pushing outward. On the other hand, gravity is constantly pulling inward, trying to collapse the star. As long as there is fuel to burn, the balance holds. But eventually, the star runs out of fuel. Without fusion to fight against gravity, the star collapses in on itself. The outer layers may explode in a brilliant supernova, but the core continues to collapse until it forms a black hole, a point of infinite density called a singularity. Surrounding this singularity is the event horizon, the ultimate boundary. Imagine drawing an invisible sphere around the black hole. Once you cross that boundary, you can never come back out. It is like stepping through a one-way door into the unknown. Even light, the fastest thing in the universe, cannot escape once it passes the event horizon. That is why black holes look black. They are cosmic traps from which nothing returns. If you were approaching a black hole in a spaceship, things would seem ordinary at first. From a safe distance, you might not even notice it. Contrary to popular belief, black holes don't go around sucking everything in. If our sun were magically replaced by a black hole of the same mass, Earth would keep orbiting in the same path. It would simply get very cold and dark because the sun's light would be gone. But as you draw closer to a real black hole, the view becomes stranger. The stars behind it start to warp, bending around the edges. This is due to gravitational lensing, an effect predicted by Einstein's theory of relativity. Space itself is curved by the black hole's gravity, and light follows that curve, creating a ring of distorted starlight around the black hole. As you get closer still, something even stranger happens. Imagine your friends are watching you from a safe distance, perhaps orbiting far away with their cameras. To them, it looks like you are moving slower and slower. Your spaceship appears to freeze near the event horizon, fading into red as light struggles to escape. In their reality, you never actually fall in. You simply become dimmer and slower until you vanish from view. But from your perspective, nothing unusual happens at all. Your clocks tick normally, your heart beats normally, and as you cross the event horizon, you feel no boundary, no sudden change. Yet at that exact moment, your fate is sealed. Inside the event horizon, all paths lead inward. There is no way to turn around, no way to escape. Even if you had rockets more powerful than anything ever imagined, they would only carry you deeper inside. Gravity is no longer just a pull. It becomes an irresistible command. Now comes the terrifying part of this journey. Gravity does not pull on every part of your body equally. Your feet are closer to the black hole than your head, and therefore experience a stronger force. The difference may start small, but it grows rapidly as you fall. Soon, the force on your feet is thousands, even millions of times stronger than on your head. The result is that your body begins to stretch. First, you might feel a powerful tug, as if you were being pulled in two directions. But as you move closer, the stretching becomes extreme. Your body elongates into a thin strand, like spaghetti. Scientists actually call this process spaghettification. Eventually, the forces are so strong that even the molecules of your body are torn apart. Atoms themselves are ripped into subatomic particles, falling one after another toward the singularity. What lies at the end of this journey is one of the greatest mysteries in science. Einstein's general relativity tells us that everything collapses into the singularity, a place of infinite density where the known laws of physics break down. But infinities are usually a sign that our theories are incomplete. Quantum physics, which describes the tiniest particles of the universe, suggests that information might never truly disappear. This has led to one of the most famous puzzles in modern physics, the black hole information paradox. If nothing can escape a black hole, where does the information about what fell in go? Is it destroyed, or is it somehow preserved on the surface of the event horizon, like a cosmic hologram? No one knows for sure. Another question is whether black holes could be connected to other regions of the universe through tunnels called wormholes. If such tunnels exist, perhaps falling into a black hole might not mean destruction, but transportation. Could you emerge somewhere else, in a different galaxy, or even in a different universe? These ideas remain speculative, but they remind us that black holes are not just objects of fear. They are windows into the deepest mysteries of reality. Not all black holes are the same, either. Some are relatively small, only a few times the mass of our Sun. These are called stellar black holes. Others, however, are monsters, supermassive black holes millions or even billions of times more massive. One of these giants sits at the center of our own galaxy, the Milky Way. It is called Sagittarius A*, and it contains the mass of about 4 million suns. Interestingly, if you were falling into a supermassive black hole, the spaghettification process would not happen immediately. The event horizon of such a black hole is so large that the difference in gravity between your head and feet would be small at first. You could drift inside for a while before being torn apart. This delay makes supermassive black holes even more fascinating, because they could allow matter to exist briefly in a region where the laws of physics are unlike anything we know. Time itself behaves strangely near a black hole. To the outside world, you appear frozen forever on the horizon. To you, the fall lasts only minutes before you reach the singularity. But relativity tells us that near the singularity, space and time exchange roles. Time becomes a direction you cannot avoid moving in, just like space forces you inward. In that sense, falling into a black hole is not just traveling through space, but traveling into a future that no one can return from. Could anyone survive this journey? The simple answer is no. The forces involved are so extreme that nothing could withstand them. But the more complex answer leaves room for imagination. If black holes are connected to wormholes, if quantum physics preserves information in ways we don't yet understand, then perhaps falling into a black hole is not the end, but a doorway. A doorway we cannot see through, but one that hints at possibilities beyond our imagination. So, what happens if you fall into a black hole? First, you would see light bending and stars warping around you. Then, as you crossed the horizon, you would find that time itself plays tricks. You would stretch into a thin strand, spaghettified by gravity, and finally vanish into the singularity, a place where physics itself fails. To the outside world, you would be frozen forever at the edge, but to you, the journey would end quickly in a realm beyond comprehension. Black holes remind us that the universe is not only bigger than we think, it is stranger than we can think. They are the ultimate mysteries of space, objects that destroy everything yet teach us so much about the nature of reality. And perhaps that is why we find them so fascinating, even though they terrify us.